This video will cover section 2.4, dividing polynomials and the remainder and factor theorems. Before we start with the long division of polynomials, we want to review how you divide integers. And so here we have 737 divided by 21. So we know that because we have a two-digit number here, 21, we must take the first two digits of the 737. By the way, the number cell we have here, the one inside is called the dividend. The one outside is the divisor, the one performing the division. So if we divide 21 divided by 73 divided by 21, I believe that goes in 3 times. So then after that, you know that you multiply 3 times 21, so that is 63. And then after that, you'll know that you have to subtract, correct? So if you subtract 73 minus 63, you get 10. Now, if you try to divide 10 divided by 21, you're not going to get an integer. So what you need to do here is drop the next number, which is 7. Now, if you divide 107 by 21, that will go in 5 times. And after that, you multiply 5 times 1, that is 5, and then 5 times 2, which is 10. So that will be a total of 105. After that, you subtract. And so 107 minus 105, that is equal to 2. Okay, so let's just establish how we call those numbers. And so 35, what is the name of that? The quotient. Very good. So that is the result of the function, correct? And then the number that we have down here, what is the name of that? Remainder, right? Not the reminder, the remainder. Okay, so now we're going to follow the same steps to do the long division, and this is something that we did in Algebra 2. So here we notice that we have 2 terms in the divisor. So because of that, we'll have to take the first 2 terms of the dividend. But what we're only dividing is the first term divided by the first term of the dividend divided by the first term of the divisor. So here, if you're not so sure what to write on the quotient, you could just use some scratch paper and divide x squared divided by x. And if you follow the rules of exponents, you know that that will be equal to x. So that x goes up here. Now, what we're going to do is similar to what we did here with the number 3. We multiplied 3 times 21. So we're going to do the same thing here. We're going to multiply x times 3, and that is 3x, positive. And then we multiply x times x, and that will be x squared. The next step here is to subtract, right? And so this turns into negative, and this will also turn into negative. 10x minus 3x is 7x, and x squared minus x squared is just 0, or we may say they cancel. Now here it's important to remember that you have positive 10 and negative 3, so therefore this term will be positive, 7x. After that, you drop the next term, which is 21. And then what you will do is take the first term here, which is 7x, and divide that by x. If you are not sure what the answer is, then you must write it down. 7x divided by x, and so that will be equal to 7. Positive 7. Okay, so after that, you take that term in the quotient, 7, and you multiply it times x. You get positive 7x. And you do the same times 7 times 3, and that would be positive 21. Now, what is the next step here? You subtract. Okay. And so here, 7x minus 7x is 0. 21 minus 21 is also 0. So here what we know is that the remainder it is equal to 0. So again, we have this one, which is the quotient. This is the remainder. This one here is the divisor, the one performing the division, and the one inside, it's the dividend. Okay, so the box that we have here, long division of polynomials, it has the same instructions of what I just explained, so let's go over it. First thing you do is arrange the terms of both the dividend and divisor in descending powers of any variable. So what does that mean, descending powers?
Greatest degree goes first and then you go
down. So you start from the greatest power and then you go down. Did we have to do that on our example? No. We didn't, right? It was already done for us. Okay, so next step is to divide the first term in the dividend by the first term in the divisor. And that's what we did. Next step is to multiply every term in the divisor by the first term in the quotient. We did that. Next step is to subtract. We did that as well. The product from the dividend. So that's why I was making those sign changes. I was and I was trying to make emphasis by marking them in red, right? I know that some of you are going to try to do that in your head. I would suggest that you don't, okay? Just write down what the product is and then change the sign. Next thing is to bring down the next term. So that's what we were doing, like we did here in the case with the with the 21, when we brought this 21 down. So you bring down the term, the next term, and then after that, you use that new expression in the dividend, as the dividend, to repeat the process. So what we mean by use that new expression as the dividend, that's what we did here with 7x over 21, and we divided 7x over x. Okay, so if you guys want to take a minute to look at it, let me know if you have a question. So for example 2, we're going to do the same thing, long division of polynomials. Do you have a tardy pass? But if you guys notice, the first one, the polynomial that is mentioned first, that will be the dividend. And the other one, it is the divisor. But you notice that the dividend is not written in descending order. It's actually written in ascending order, right? So what we need to do is rearrange it so that we start with the number or the term that has the highest power. So in that case, that will be 6x cubed minus x squared minus 5x plus 4. All of that will be divided by 3x minus 2. So I changed the arrangement of the terms here. I started with 6x cubed, then negative x squared, then negative 5x, and then positive 4. And I know that 4 is positive because there's no sign in front of it, right? Okay, so now, Samantha, what should I do next?
divide 3x.
Okay, so 3x will be the divisor, but what are we dividing? 6x cubed, very good. And remember, I told you, if you cannot do this in your head, just write it down. It doesn't take that long. So if we divide 6 divided by 3, Brandon, what do we get?
2x squared.
2x squared, thank you. So 6 by 3 divided by 3 is 2, and then here if we subtract the exponents, we will get x squared. So very nice. 2x squared. Okay, so Sassini, what is the next step? I can't hear you. Okay, so 2x squared times 3x, that will be 6x cubed. And we know it's 6x cubed because you multiply the coefficients, 2 times 3, that is 6. And then with the exponents, Sassini is actually adding the exponents, right? Which that's the correct rule. Okay, now we multiply the term in the quotient times the negative 2. So what would that be, Jesus?
12x.
No, we want negative 2 times that, times 2x squared.
4x squared.
4x squared. Negative or positive? Negative. Okay. Now, what is the next step, Karina?
You subtract, so the 6x cubed would become negative, and the 2 is supposed to be 4, but it becomes positive.
Oh, it's supposed to be a 4. Thanks. Is that what you said? Oh, sorry. Okay, so we correct that and then we make it positive. All right, now we subtract. So here, these two terms are opposite, so they cancel because they're equal to 0. Now here we have positive 4x squared minus x squared, so that will be 3x squared. Are we okay with that step? All right. What is the next step, Kitty? Bring down the negative 5x. Good. All right. And now, Rebecca, what is the next step? I'm sorry, I can't hear you. So now we consider this one our dividend, correct? So we need to divide something by something. No. So this is the dividend, and this one here is the divisor. So 3x squared divided by 3x. And what will that give me? X. Very good. So subtract the exponents. 3 divided by 3 is 1. X squared divided by x is x. So will that be positive or negative? Positive. And that goes up here. So that's part of the quotient. Okay. Now what's the next step, Ivana? Okay, so x times 3x, what will that give me? 3x squared. And then x times negative 2. Positive or negative? Negative. Very good. Now, what's the next step? Alfonso. Okay, so 3x becomes negative, and the negative 2x positive. Very good. Because we are subtracting, right? So here 3x squared minus 3x squared is equal to 0. We don't need to write it unless you want to. And then we combine like terms of the x's, and that will be positive 2x minus 5x. What would that equal to? Negative 3x. Okay. So what is the next step, Janine? Bring down the 4, and that will be positive 4. Okay, and then, Oleg, what is x? Okay, and how do we find that one?
So you have the difference between 3x and negative 3x, so that would be negative 1.
Okay, so not the difference, but the division or the quotient, right? So negative 3x divided by 3x, and what do you say that was? Negative 1. Okay, and that goes up here as the next term of the quotient. Okay, Bastian was next.
Multiply negative 1 by 3x.
Okay, so what is that equal to?
Negative 3x.
Negative 3x. And then what else?
And then by negative 2. And then that would add to plus 2.
plus 2.
And,
And
change
keep
it.
that in mind, negative times negative, that will be positive. So you need to be very, very careful with all those signs, okay? Please don't rush, because then you get mad at my math lab, and in fact, you're the one making the mistakes. So then you were saying you subtract, right? So that turns into positive, this turns into negative. 3x minus 3x is 0, and then we have positive 4 minus 2, that is equal to 2. So let's look at the difference between the first problem we did and the second. The first problem, the remainder was equal to 0, right? Yes? Okay. So what we could say here is that the polynomial x squared plus 10x plus 21 is equal to x plus 3 times x plus 7. In other words, the quotient is a factor and also the divisor, because the remainder is 0. So this is pretty much what this section is about, okay? Remember, sometimes it's not that easy to factor, so sometimes relying on the long division or synthetic division, which we're going to do next, that could also be useful. Now, I could add the remainder, it would just be 0. Now, if we go to the second problem, we don't have that. In fact, the remainder is 2. So what I could say here is that the polynomial 6x cubed minus x squared minus 5x plus 4 is equal to the quotient 2x squared plus x minus 1, and then plus the remainder. But that remainder is not going to be just 2. It will be 2 divided by what? 3x over 2. So think about a number. Well, actually, we do have a division here. So when we divided 737, if you remember mixed fractions back in the day when you were in elementary, it was the quotient, which is 35, plus 21 over, I'm sorry, not 21, but the remainder, which was 2, over 21, right? Of course, mixed fractions, you guys used to write them this way. I don't want you to do this in pre-calc. Someone did that on the test, and I actually took points off. Right, Karina?
Yeah.
And the reason for that is that this to me says they're multiplying. Right? So that's why I'm writing it with a plus. Alright, so let's go back to the second slide, second problem. Okay, now this one is going to be just a little more challenging. So first we check that the dividend is written in descending order, meaning the highest power first. So we have 6x to the 4th plus 5x cubed. Now you notice there is no x squared here, right? Now you don't have to, but I will suggest that you leave that space with a 0x squared. The next term will be 3x and then minus 5. All of that is being divided by 3x squared minus 2x. Okay, so we're going to follow the same steps. 6x to the 4th divided by 3x squared. So remember, if you don't know what it is, you write it down. 6x to the 4th divided by 3x squared. So that is 6 divided by 3, that is 2. And if we subtract the exponents, we will get x squared. So that's the first term of the quotient. If you want to try to do it on your own and then just keep checking with me, that will help out. It doesn't really matter. I like to put it on the second one because I know that I'm gonna take the first two terms, but it doesn't really matter. Yes.
Oh, no, it's because he said that they got it up.
That was mine. The one that was inside, that was ours.
Oh, okay,
But the one they left is all outside.
okay.
Okay, so now from here, we take the first term of the quotient, multiply, so 2x squared times 3x squared, that is 6x to the 4. Then 2x squared times negative 2x, that will be negative 4x cubed. And then we all know we have to subtract, so we change the signs. Here, they're opposite, so they cancel or they go to 0. Then we have 5x cubed plus 4x cubed, that will be positive 9x cubed. If you guys see that I make a mistake, please let me know. Okay, now what is the next step? Bring down the next term, right? So plus 0x squared. And this is why I recommend that you guys keep that space, because if you were to bring down the 3x, then it could lead to a little bit of confusion. All right, and you guys will see why. After we multiply it, it will make a little more sense. Okay, so now what's the next step, Alexandria?
Where are we?
So I finished dropping the next term. So now this is my dividend.
Divide 9x cubed by 3x squared.
And what does that equal to?
3x.
3x, very good. So positive 3x, that's my next term on the quotient. Bless you. And then my next step is to multiply. So 3x times 3x squared, that will be 9x to the third power, right? Because we add the exponents. Next thing is positive 3x times negative 2x, that will be negative 6x squared. And so this is why I recommend that you guys keep that space of the x squared, because if you would have had the 3x, then you would have been like, okay, what am I supposed to do now? Right? But it's not really necessary, that's just optional. So now we subtract, so we're going to change the sign of this one and this one. Those two are opposites, so that equals to 0. And then is 6x squared plus 0x squared is just 6x squared. Now the next step, what will be the next step, Brianna? So positive 3x. And then Ruby, what's the next step?
Divide 3x squared.
Not 3x? 6x squared.
By 3x squared.
Okay, so that is 2. Very good. So that is the next term on the quotient, plus 2. And now note, just like we do with numbers, we need to multiply. So 2 times 3x squared, that will be 6x squared. 2 times negative 2x, it is negative 4x. And then what is our next step? Anyone? Subtract or change the signs, right? So negative, positive. So that cancels out. 0, and then 3x plus 4x, that's 7x. Now what is our next step?
We
Bring down the next term, right? Minus 5. Now here, if you guys notice, the degree of the, I'm going to just go ahead and call it the remainder because we cannot go any further, and I'll tell you why. What is the degree of the remainder? A 1. And what is the degree of the divisor?
2.
A 2. So once the degree of the remainder is lower than the degree of the divisor, that's your cue to stop. There's no more division. Okay? All right. So here we have something called the division algorithm. Okay. So we have if f of x and d of x are polynomials, with d of x is not equaling 0, and the degree of d of x is less than or equal to the degree of f of x. Now, then there is this unique polynomials, q of x and r of x, such that, and then we have it there. Now, if you guys notice, there are using letters d, q, and r for convenience, right? So f of x, it is the dividend. D of x is the divisor. And then we have here the quotient is q of x. And the remainder is r of x. So now going back to the first problem that I had, can I borrow your... Okay, I'm going to use the example 2 actually. So we have something like 6x cubed minus x squared minus 5x plus 4 is equal to 2x squared plus x minus 1 plus 2 over 3x minus 2. Here we go. Thank you. But now, what will happen if I multiply by the give me a second. So this is the quotient. Oh, I'm sorry, I am missing one thing. And you might want to make this correction on your paper. Right here, I should have had the divisor. Divided by 3x minus 2. I apologize for that. So please correct your paper. Okay. So going back here, it's all of that divided by 3x minus 2. And now I'm going to write the same thing. Can someone please tell them to turn off the music? Thank you. We're having a dual credit precalculus. Come on. Okay, so it's the same statement, but what I'm going to do is actually multiply by the divisor. Okay, the one in red. So what will happen if I multiply here 3x minus 2 by all the stuff here in parentheses? What will happen with the denominator? Thank you, Rebecca. So the bottom cancels. So then we have 6x to the third power minus x squared minus 5x plus 4. Now let's look at the right side. So we will have to distribute this one. And so I'm just going to write it that way. And let me see which one I want first. Yeah, I want the divisor first. 3x minus 2 times the quotient. And then since we know we need to multiply that one times this fraction, what will happen there? Denominator will also cancel, right?
So would it be plus 2 then?
It will just be plus 2. Very good. So now if we look at the division algorithm, that's actually what it's telling us. Right here we have the dividend. So the dividend is equal to the divisor times the quotient, and then plus the remainder. Now in this case, it's just 2, not 2 divided by the divisor. So the reason here it was divided as a fraction is because here we were still representing that with as a quotient, as a division, or as a fraction. Okay. Let me see if I did the ones on this side right. Okay, so here I also made a mistake. This should be 737 divided by 21. And this should have been that divided by x plus 3. All right, so let's go to the third slide. Well, look at the second slide, please, and let me know if you have a question about it. When I give you your study guide, so when is your next exam, guys? Okay, so that gives us 2 weeks, right? Okay, so I will post a review on Edmodo today, and then I'll have the printed copies for you guys on Friday, okay? But I will post it today so that if you want to, you can start looking into it. All right, so I'm going to go to the next one. Just give them to Rudy. Look at the previous slide and let me know if you have a question. So I'm going to write a statement. Do you have a question? You could ask me. Okay. Is it from the previous one? Yeah, where is it from? Okay. All right. So what is the question? Or Brandon had the question? So you guys were just talking about the problem? I can't hear the last thing you said. Okay. So there's no problem with the problem? Okay. Okay, so I want you guys to write the following statement. We can use synthetic division to divide polynomials if the divisor is of the form x minus c. And you guys know we cover this in algebra 2, right? Now, what I would like for you guys to do, I'm going to pause the video and I'm going to give you a few minutes for you to work this problem out. You can work it by yourself, or you can work it with a partner. Okay? I'm going to give you guys a few minutes to do that. After that, we're going to go over synthetic division and see if we get the same answer. Okay, so I'm not going to talk because it actually hurts when I talk. I'm just going to write down the answer for this one. You may check with yours, okay? If I make a mistake, let me know.
You made a mistake.
I did?
The x squared is supposed to be x cubed. Because x times x squared is x cubed.
Okay. I was checking. we all get the same? Okay,
Yes.
perfect. So if I do that here, you guys know how I'm making a lot of emphasis with the negative signs, right? Like changing the signs. So when we do synthetic division, instead of changing the sign through every step, we only change the sign at the beginning, okay? This also comes from the fact that, well, this one is not a factor, so I can't really call it a factor, but if it was a factor, we would have x minus 3 equaling 0, then x will be equal to what? Positive 3, right? So you could also think of it in those terms. Not necessarily that it is a factor, because in this case it's not, right? We had a remainder. So sometimes I get asked, why do we have a positive 3 here? So that could be an idea to think about it, or another reason is so that we don't have to keep subtracting, right? So when we perform synthetic division, first thing we do is we drop the first term, and then we multiply. 3 times 1, that is 3. There's no need to change the signs here, because we're not going to subtract. We're going to add. So 4 plus 3 is 7. And then 3 times 7 is 21. And then we add, and when I say add, I know I have a minus 5, but that is just adding a negative number, okay? If I was subtracting, I would change the sign of one of them. So, or in other words, we're combining like terms. Okay, so 21 minus 5, that is equal to 16. And then we multiply 3 times 16, that is positive 48. 48 plus 5 is 53. And so you can see here, the last number is going to be the remainder. Sometimes that remainder might be 0, and if that is the case, then we can assume that the divisor is a factor of it, like the case of the very first example. Now, one thing to consider here is that if you start with a dividend of degree 3, that 1 is the coefficient of x to the third, the 4 is the coefficient of x squared, the negative 5 is the coefficient of x, and 5 is a constant term. Now here we are dividing by 3, but in fact we're dividing by a divisor of degree 1, right? And in fact that is one of the conditions for you to use synthetic division. It must be degree 1. And also the coefficient must be equal to 1 of the divisor. So if that is the case, once you divide, your quotient will be 1 degree less of what the dividend was. So this 1 will be representing x squared, the 7 represents x, and 16 represents the constant term, or the number. Okay, so all the instructions that you have there are for you to read. I'm not going to read it because it actually hurts when I talk. So I'm going to go to the next slide, and let's just practice more of those synthetic division problems. Okay, one important, very important thing with synthetic division, you have to make sure that your dividend is in descending order. Remember, we talk about that word. We start with the greatest power, and then we go down. So the last term should be the constant. Now, another very important thing to consider is that you need to make up with zeros for any missing term. And so if you notice here, I'm going to rewrite the dividend. So we have 5x cubed, and then the next term is 6x. There is no x squared, right? So when we do long division, it's an option if you want to make up for that space. When you do synthetic, you must. So in this case, we will have plus 0x squared plus 6x plus 8. So that's what we're going to be dividing by x plus 2. So when we do synthetic division, the number that goes inside the square will be the opposite of this plus 2. So that's going to be a negative 2. And that will save us the trouble of subtracting, right? Or changing the signs. So now we list the coefficients here, and we'll make sure that we're not missing any. So our powers must be 3, 2, 1, and this will be x to the power 0, correct? That's the constant term. So the coefficients are 5, 0, 6, and 8. So we drop the first term, coefficient. And then negative 2 times 5, it's negative 10. Combine like terms, so that 0 minus 10 is negative 10. Negative 2 times negative 10 is negative 20. 6 minus 20 is negative 26. I'm sorry.
The 20 should be positive.
Oh, yes. So negative 2 times negative 10 is positive. 20 plus 6 is positive 26. And then 26 times negative 2 is negative 52. Then we combine our terms, so 8 minus 52 is negative 44.
Yes.
Okay. So that is going to be the remainder. All right. Now from here, let's just go ahead and write it down. So we could say that we started with something of degree 3. So the quotient will start with degree 2. So the 5 represents 5x squared, the negative 10 represents negative 10x, and the 26 is just a constant term, and then here we have the remainder. So by using the remainder theorem, I'm going to say that the polynomial 5x cubed plus 6x plus 8 is equal to the divisor, which is x plus 2, right here, times the quotient, which is here, 5x squared minus 10x plus 26, and then plus the remainder, and the remainder is negative 44. Okay. Now, we're going to evaluate f at c. In this case, c is so what will be c? Positive 2 or negative 2? Negative, because we have x minus 2. Okay? If you want a shortcut for this, it will be always the opposite of this term. So remember, when we do synthetic division, that was the statement that we wrote down. You're dividing in this form, x minus c. Okay, so what I want to evaluate here is f of negative 2. So we're going to let c equal to negative 2. In other words, it's going to be the same number that you put inside this little box. Okay, that will be c. Okay, so f of negative 2 for the same polynomial that we had as our dividend right here, it will be 5 times negative 2 to the third power plus 6 times negative 2 plus 8. Here I'm going to do the exponents first, so it will be 5 times, what is negative 2 to the third power?
Negative.
Negative. So negative, because it's negative times negative times negative. Then we have plus 6 times, well, minus. Okay, so now then we multiply 5 times negative 8 is negative 40. 6 times negative 2 is negative 12, and then we have plus 8. Okay, so can you guys please calculate that? Okay, so someone else, just to confirm. What do you get, Basket? Yeah, okay. Negative 44. So do you guys notice how the function value at f of negative 2 is the same as the remainder, right? So that's why we call this the remainder theorem. So it says if the polynomial f of x is divided by x minus c, then the remainder is f of c. In other words, the function value. Sazini, are you paying attention? Okay, I want you looking at the board. Okay, so let me see what statement I want you to write there. So we're gonna just rewrite the remainder theorem. If a polynomial, thank you, is divided by x minus c, that will be using long division. The remainder is the value of the polynomial at C. For your exam, if I ask you, use the remainder theorem to find f of 3. If you do something like f of 3 is equal to, I don't know, 3 squared plus 4, 3 plus 7, random example, I'm going to count that wrong because that is not using the remainder theorem, okay? So what should you do if I ask you to use the remainder theorem? What kind of division should you use? Synthetic division, and then use the remainder to give your answer. Okay, so I'm warning you, don't say I didn't say that. It's on video. Okay, if I ask you use the remainder theorem, you must use synthetic division.
So we do like the little, like negative little square and then.
Yeah, so you will do that with a 3. And then whatever you get here for the remainder, that will be your answer. Okay? Okay, so I want you guys to practice that one. Use the remainder theorem to find f of 2. So that means do not substitute x with a 2. You actually use synthetic division. Okay? Just practice. While you're doing that, I'll write the statement that I want you to copy here, and then we will check our answers. Okay, so we're going to review the answer for example 5, and since here they're giving us f of 2, that will be the exact same number that goes inside the box, okay? If we had been given the divisor in this form as x minus 2, then yes, we will take the opposite of that constant term, okay? Now, what we get here, so the way you will answer your question is by the remainder theorem, should be capital. F of 2 is equal to 5. So no direct substitution, right? So what will happen if you use direct substitution during the test? It's wrong, okay? Because you're not using the remainder theorem. Of course, you could use it to check your answer. It wouldn't hurt. All right, so now I want you guys to copy the statement that you see here. if f of c is equal to 0, so that is just like reversing the statement, then x minus c is the factor of f of x. So like the converse of your previous statement. Okay, so we'll just stop here, and then we'll finish those last statements. So